Let's talk about centrifugal pump cavitation. In this video, we'll be breaking it down in a way that everyone can understand it. Cavitation is when vapor bubbles implode on the pump's impeller. Here's a slow-mo visual of vapor bubbles imploding while submerged in liquid. Here's an image of surface pitting on a pump's impeller, which was a result of excessive cavitation. When most people think vapor bubbles, they imagine bubbles they blew as a kid and think, what harm could bubbles do? How do vapor bubbles cause this? Well, have you ever walked in the rain? Doesn't hurt too bad, right? What about riding a dirt bike, four-wheel, or a boat in the rain? Hurts a lot more? Well, imagine being in the Daytona 500 in a convertible while it's raining. You have to keep in mind the impeller is spinning thousands of times per minute and there's supposed to be only liquid entering. So the same way the rain at Daytona is going to slam up against you, the vapor bubbles are going to implode on the pump's impeller. If cavitation is occurring, some of the symptoms you will see is lack of flow, excessive vibration, and abnormal sounds coming from the inside of your pump. For example, here's the sound of a pump cavitating. Kind of sounds as if gravel is being spun around and shaken up inside your pump. Well, it's not gravel. That is those vapor bubbles imploding on your pump's impeller. Cavitation is always the result of lack of flow going through your pump. There are multiple things that could cause the lack of flow, which we'll be covering in our next video. It's a common misconception that cavitation only occurs from sucking air into your pump due to a tank or tower level being too low. While this does result in cavitation, it's not the only cause of cavitation. Where else could the vapor bubbles come from? Well, it depends on if it's suction cavitation or discharge cavitation. With discharge cavitation, if flow through your pump is restricted due to something happening downstream or the discharge head pressure is too high, the liquid is stuck inside the pump casing while the impeller spins thousands of RPMs. This causes friction. Friction equals heat. Heat causes boiling. So the vapor bubbles are actually boiled processed liquid. The lack of flow causes friction, which causes the liquid to boil and result in cavitation. Suction cavitation is a little different. To understand suction cavitation, we must first understand what net positive suction head, aka NPSH, is. NPSH is a measure of the pressure available at the pump suction to prevent the liquid from boiling and turning into vapor. NPSH required is determined by the manufacturer or the NPSH chart. There is always a pressure drop as the liquid enters the pump suction eye and is accelerated. If the NPSH available drops below the NPSH required, the pressure at the suction eye drops below the liquid's vapor pressure, essentially creating a vacuum and causing it to boil. In other words, there must be enough pressure on the suction so that this pressure drop doesn't cause the pressure of the liquid to drop low enough to cause the liquid to boil. The NPSH required is calculated to ensure this doesn't happen.